Good morning everyone. Today we are going to perform qualitative analysis of an inorganic salt. Now in our previous semester we had done the quantitative analysis where we had determined the concentration of an acid or of a base. Okay, but now in this semester we are going to analyze the salt solution qualitatively. Now, first of all, what is qualitative analysis? It is that branch of chemistry that determines the chemical composition of a salt. We are going to analyze the constituent ions, the individual constituent ions of a salt solution. Now, suppose we are taking NaCl. Now, NaCl, when we dissolve in water, it is going to dissociate into Na plus and Cl minus ions. We are taking an inorganic salt because in inorganic compounds, the bonding is basically ionic. So, it is very easy to dissociate into a positive radical and a negative radical. So, for this analysis to conduct, we have to first prepare an original solution. What is original solution? It is a concentrated or saturated solution of salt. Means it is an aqueous or transparent salt solution and it is dissolved in a suitable solvent. It can be dilute HCl, it can be H2O, but we are going to dissolve the salt in H2O. That means we are going to provide you the water soluble salts, the salts which are soluble in water. Let's take this reaction NaOH plus HCl, it is giving NaCl plus water. Now NaCl is my salt, but we see that NaOH is the base and we derived this positive ion from the base. That's why we call it as the basic radical cation. Similarly, we derived this chloride ion from the acid, which is the HCl. That's why we call it as the acid radical. So basic radical or cation is my positive radical, or acidic radical or anion is my negative radical. Now, as the name suggests, systematic qualitative analysis means we have to analyze the salt in a systematic mannered way. There are 4 or 5 steps involved in which we have to determine the constituent ions, one positive ion and one negative ion. First of all, we have to do the preliminary test. Means how my salt solution looks. We are going to provide you with the original solution, means the sample, the salt, which we also call it as the OS. It is soluble in water, so first you have to see the physical appearance of it. What is its color? If it is white or if it is not having any characteristic color, we will say that it is colorless. If it is having a color, say blue, we will say that copper ion may be present. If it is containing a green color, we will say that maybe ferrous ion may be present. Next, we have to do the litmus test. This we do for testing the acidity or alkalinity of the solution. So, by litmus test, we will know if the solution is acidic or basic. The third is flame test. Now, every metal ion or every cation has a characteristic emission spectrum, means a flame color. Some metal ions, they may not have any flame color. So for those metal salts which will not have any flame color, we will write it as no particular flame. But those metal ions which give a characteristic flame, we will write some color. That yes, golden yellow is there, I will say sodium ion is there. If I say that pink flame is coming, I will say that potassium ion is there. Now for doing this flame test, we need a platinum wire. So we analyze the color of the flame through that platinum wire, and we introduce the solution in it, the salt in it, and we analyze the flame. Next is borax bead test. This test is performed only for colored solutions. Solutions which are colored, we perform this test. Next is the wet test for positive radicals. In positive radicals, these cations, they are categorized into 7 groups. First, second, third A, third B, fourth, fifth A and fifth B. Now in every group you have 3 or 4 metal cations. You have to categorize or you have to analyze according to that. After that comes the group analysis. The cations, we first analyze in which group my precipitates are coming. Then we determine the group analysis and then we go for conformative test. Similar is the process for negative ions. Now, before moving to the scheme, we have to first know a term precipitates. We have done this in our previous semester, but what are precipitates? These are the solid that forms out of solution. Means this is a product which is insoluble. Suppose I have taken silver nitrate and sodium chloride. These two reacts to form silver chloride and sodium nitrate. Now my sodium nitrate, it is soluble in this solution, but AgCl is not soluble. So this comes as a white precipitate. Precipitate, we also call it as PPT. So these are the two products. One is insoluble and one is soluble. So my insoluble products, they are the precipitates. So we will have to analyze according to that. Now this is the scheme for your analysis to perform. You will be provided with the original solution, means your sample. This is the particular scheme where you determine which cations are there. First, you have to add dilute HCl to the original solution. This is the first step. When you add dilute HCl to the OS, there are two outcomes or there are two possibilities. There, precipitates may come or no precipitates will be there. If the precipitates come, I'll say that group 1 is present. The cations which are present in group 1, they are lead ion, silver ion and mercury ion. We have 3 ions in the group 1. So if precipitates come, I can say that either of these 3 ions are present in my original solution. If there are no precipitates, if it is crystal clear, what I'll do, I'll move to the next step.
I will take OS plus dilute HCl plus H2S.
Again, there are two possibilities. Precipitates may come or precipitates may not come. If precipitates come, I'll say that group 2 is present. Now in group 2, we again have 3 metal cations, copper, cadmium and tin. If no precipitates are there, none of these ions are present. So if no precipitate is there, I'll again move to my next step. I'll add ammonium chloride plus ammonium hydroxide to my OS. And again I'll check if precipitates are coming or not. If precipitates are coming, I'll say that group 3A is present. Now these are the ions which are present in group 3A. Ferric, aluminium, chromium and ferrous ion. Again, if no precipitates are there, I'll again pass to my next step. I'll pass OS plus NH4Cl plus NH4OH plus H2S. And again I'll check if precipitates are coming or not. So if precipitates are coming, I'll say that group 3B is present. In group 3B, we again have these 4 metal cations. If precipitates are not there, I'll move to my next step. I'll check if 4th group is present or not. So I'll take OS plus NH4Cl plus NH4OH plus ammonium carbonate. Again I'll check if precipitates are there or not. If precipitates are there, then my group 4 is present. In my group 4, I have calcium or barium ions. If precipitates are there, either of these ions may be present. If no precipitates are there, I'll again check if the ions are present in 5th A group or 5th B group. So to check that, we add OS plus NH4Cl plus NH4OH plus sodium hydrogen phosphate. I'll check if precipitates are there. I'll say that 5th A group is present. In 5th A group, you have a single ion, that is magnesium ion. And if there are no precipitates, I'll confirm that 5th B group is present. Now, after this, we will conclude that if no precipitates are there up to this point, we will conclude that in the 5th B group, either of these 3 ions may be present.